Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 5. This is Section 15.2, Problem number 5. We want to find the integral of x squared plus 3x minus 8 in parentheses to the 5.4 power times 2x plus 3 in parentheses dx. So, if the exponent here, 5.4 power, were a whole number, if we wanted to, we could factor out many sets of parentheses, like do out a big FOIL and simplify it, which would be more work than it'd be worth. It'd still be better to do the substitution method. But because it's not a whole number, we don't even have that option. We really have to go with the substitution method. So for the substitution method, we want to choose a value for u, start with that. And our choices are, again, stuff in the parentheses, which is the most common. We do have parentheses. The thing is, there's two sets of parentheses. But the other options don't fit. There's stuff in the denominator. This problem has no denominator. Stuff under the root, there is no root in this problem. And power of e, there is no e in this problem. So it has to be the stuff from the parentheses. But this one has two sets of parentheses. Well, the one with the exponent is the much more likely choice. So I'm going to do u is the value from the larger parentheses with the exponent, x squared plus 3x minus 8. And again, just what's in the parentheses. Notice I'm not taking the exponent of 5.4. That's not part of my u. My u is just what's inside of the parentheses. The next step after choosing a u is finding du, derivative of u. The x squared has a derivative of 2x to the first. And again, the exponent of 2 comes down times the number in front, which isn't written but understood to be 1. 2 times 1 is 2. X, 1 less power. The second power drops down to a first power. The 3x has a derivative of 3. And the minus 8 has a derivative of 0. And then you put a dx on the end for derivative with respect to x. And that derivative with respect to x applies to all this, so I do put it in parentheses. And at that point, you can see that the value du, 2x plus 3 dx, is going to match up with part of the original problem. So as I rewrite the original problem in terms of my new variable, I'm going to have u to the 5.4 and then du. So why is this better, just u to the 5.4 as opposed to the parentheses to the 5.4? When it's just one variable like this and not in parentheses, the integral is easy. It's going to be 1 over 5.4 plus 1 u to the 5.4 plus 1 plus some constant. With the parentheses, you'd have to get the variables by themselves and do out a big FOIL. And again, with a whole number you could do it, but with a decimal you can't. Whereas with just one variable, it doesn't matter if it's a decimal, you follow this format. So I'll simplify it. 1 over 5.4 plus 1 is 1 over 6.4. U to the 5.4 plus 1 is 6.4 plus a constant. And I can put it back in terms of the original variable. Instead of the u, I'll leave the 1 over 6.4 out in front and replace u with what it's equal to, which is x squared plus 3x minus 8 to the exponent of 6.4 plus a constant. And if you want to, instead of having a combination of a fraction and a decimal, off to the side on the calculator, you can go 1 divided by 6.4 equals and have an actual decimal value in front if you want. Or you could just leave 1 over 6.4.